Taints and tolerations are key concepts in Kubernetes scheduling that help control where pods are placed on nodes. Taints repel pods from nodes, while tolerations allow pods to be scheduled despite those taints. Understanding these helps ensure the right workload runs on the right machines. Taints are attributes applied to nodes that repel pods which do not have matching tolerations. They act as a repelling mechanism to prevent pods from scheduling onto nodes that are unsuitable for them. A taint consists of a key, a value, and an effect. The effect defines what happens to pods that do not tolerate the taint, such as preventing scheduling or eviction. An example of a taint involves a key called dedicated, a value of GPU, and an effect of no schedule. This means nodes with this taint will not schedule pods unless the pods explicitly tolerate this taint. The no schedule effect prevents new pods from scheduling on the node unless tolerated. Tolerations are applied to pods to allow them to be scheduled onto nodes even if those nodes have matching taints. They enable pods to tolerate the repelling effect of taints. To be effective, tolerations must match the taint in key, value, and effect, allowing the pod to run despite the node taint. A toleration example shows a key of dedicated, operator equal, value GPU, and effect no schedule. This configuration tells Kubernetes that the pod can tolerate the taint on nodes with that key and value, allowing the pod to be scheduled there despite the no schedule effect. Node affinity is a complementary concept that lets you select nodes for pods based on labels. It uses selectors to match pods to nodes, either as required conditions or soft preferences. This helps fine-tune where pods run in a Kubernetes cluster based on node attributes. Taints and tolerations work together to repel or allow pods on specific nodes. Node affinity adds another layer by specifying node selection based on labels. Together, these mechanisms provide precise control over pod placement for better resource utilization and workload management. For example, a node named GPU node can have a taint with key dedicated, value GPU, and effect no schedule. This configuration ensures that unless a pod tolerates this taint, it will not be scheduled on the GPU node. Similarly, a pod named GPU pod can have a toleration matching the taint key dedicated, value GPU, and effect no schedule. This allows the pod to be scheduled on nodes tainted for GPU workloads, bypassing the no schedule effect. Use taints to isolate nodes that have special hardware or are dedicated to specific workloads. Apply tolerations to pods that need to run on these special nodes. Combine taints and tolerations with node affinity for precise scheduling control. Avoid overusing taints as this can reduce scheduling flexibility in the cluster. Taints repel pods from nodes unless pods explicitly tolerate them. Tolerations let pods tolerate those taints to allow scheduling. Node affinity complements these concepts by specifying node selection preferences or requirements. Using all three together helps enforce precise and flexible pod scheduling policies in Kubernetes clusters.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.